All right, let's take a look at the next part of chapter 2. In this section, I had described how all the transformations worked. So adding and subtracting on the outside shifts up and down. Adding and subtracting on the inside of the function like this, moves it left and right. Multiplying on the outside, a vertical stretch, if it's bigger than 1. If it's inside, it's a horizontal shrink if it's bigger than 1. Negative on the outside reflects vertically across the x-axis. Negative on the inside reflects horizontally across the y-axis. So now, let's finish up some of these practice problems. Number 5 here, it says, given a function, f of x, describe how g of x would be obtained from f of x if g of x is equal to this. In other words, what would we do to this graph to get this graph? And if you look at them, you'll see some similarities, right? There's the 5s in both places. We see the x cubed in both places. I guess that's where the similarities end. There's some on the outside here, right? One I'm adding, one I'm subtracting. So it's going to be the same shape. We just need to shift, right? So we need to move g of x. So if we have f of x, we need to move with this plus 3. What's that going to do? It's going to move left 3. So we're going to have to move f of x left 3. And so that takes care of this plus 3. And then here, this was shifted up 1, and now it needs to shift down 2. So that's a difference of 3. So we're going to have to take f of x and move down 3. So move f of x left 3 and down 3. All right. Now we need to write an equation that matches the criteria here. So it's the shape of y equals square root of x, but reflected over the y-axis. So this is y equals square root of x. They want us to reflect over the y-axis, so it ends up over here. So it's reflecting horizontally, so that's going to be on the inside. So I know I want a negative x. And shifted down 3. How do we move it down 3? Well, that's on the vertical direction. It's going to be on the outside. We need to put plus 3. Excellent. All right, number 7. Shape of y of 1 over x, but shrunk vertically by a factor of 3. So a vertical shrink up and down, it's got to be less than 1. So factor of 3 is going to be 1/3. And left 2. How do I move left 2? If you remember its opposite, I'm going to have to add 2 on the inside. So this ends up being y equals 1/3 times 1 over x plus 2. So the times is on the outside. That'll be a vertical shrink by a factor of 3. Plus 2 on the inside will move it left 2. You could also multiply this and get this. Either one of those would be acceptable. The last one, shifted up 1 unit. How do I shift up 1? I just on the outside add 1. All right. I'm going to call number 9 enrichment. If you want to do it, great. I'll talk through it, but you can also skip ahead in the video if you'd like. The key again is just identifying what's going on. Okay, so minus 2 on the inside is going to go right 2. Plus 1 is up 1. So all I have to do is move all of my points right 2 and up 1. Right 2, 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 up 1. You're getting tired of this, aren't you? Right 2, up 1. And then just connect the dots. you'll notice it shifted the whole thing right 2 and up 1. Here, times 2 minus 3. What's that going to do? Vertical stretch by a factor of 2 times 2, and then subtract 3. You can do this on the graph and think, okay, this y value is 5 times 2 would give me 10, and minus 3 would end up here. That works fine. You could also do it on the table. If I take 5 times 2 is 10, minus 3 gives me 7. 2 times 1 gives me 2, minus 3 is negative 1. Negative 1. Negative 2 times 2 is negative 4, minus 3 is negative 7. Negative 9, negative 7, and negative 1. Here we go. I can now just plot these points. Negative 3 has a y value of negative 1. Negative 1. At negative 2, it's actually going to be negative 7. Negative 9, negative 7, and negative 1. And you see that this has been stretched in the vertical direction times 2. It's also been shifted down 3, but with that stretch, sometimes it makes it look like it went up, like right here. All right, we can do the same thing here. This is going to reflect it horizontally and then shift it up 3. I think this might be easier to do without the table because the x values are changing as well. Here we go. We've got negative 6, so it's going to flip this all the way over to positive 6, but then it's going to go up 3. So now we're up here. This one's going to flip from negative 3 to positive 3 and then shift up 3. Don't need that. This one, oops, not what I wanted. This one is going to reflect across the y-axis over to here and then up 3. Instead of positive 2, this will be over to negative 2 and up 3. This, instead of positive 3, will be negative 3 and up 3. Instead of 4, it'll be negative 4 and up 3. And instead of 5, it'll be positive 5 and up 3. So that's a little confusing. I'm going to erase these. I feel like I should have crossed that one off. Here we go. Looks something like that. Again, this is really just enrichment here. Challenge, you might call it. 1/3 on the inside. What's that going to do? Horizontal. You might be tempted to say shrink, but it's a horizontal stretch by a factor of 3. So everything's going to be 3 times farther from the y-axis. So instead of being at negative 6, this is going to be at negative 18, which is going to be like way out here. Instead of being at negative 3, it's now going to be at negative 9. Instead of being at 1, it'll be 3 times farther at 3. Instead of being out 2, this one will end up being out times 2 to 6. This one will end up being out times 3, which is 9. This one here, instead of 4, will be 12. And instead of 5, we're looking at 15. So you get the idea. This is really stretched out in the horizontal direction. Something like that. All right. Let's take a look at section 2.2. A lot of algebraic work here. We're going to talk about adding products, adding, subtracting, multiplying, and dividing functions. So you're used to doing it with numbers. We're now going to do it with two functions. Key idea right here is just notation. Okay? So when you see this, it doesn't mean to add f plus g. It means to add the function f plus the function g, and so on. So here we go. How do we find f of 3? I'm sure you're fine with this. We just plug 3 into the function. So we get 3 plus 2 is 5. G, plug in 3 for x, and we get 11. Now, what is f plus g of 3? That means that I need to take f of 3, and I need to add g of 3 to it. When I do that, I get 5 plus 11. That gives me 16. Here I would subtract them. F of 3 minus g of 3. So I get 5 minus 11, negative 6. Multiplication. I think you get the idea here, right? So 5 times 11. And division. I'm going to leave that as 5 11s. Okay. Now it says do the same thing only with x, state the domain. F of x, well, that's x plus 2. G of x then, we've got 2x plus 5. Here it says to add f of x and g of x together. So I just replace f of x with f of x. Take that function. And then I need to add g of x, which is 2x plus 5. Now, since these are, this is a plus here. I don't want to FOIL that. I just want to add these. So I've got an x term and a 2x term. That's 3x's plus 7. Here I subtract the 2. Here the parentheses are pretty important. If you leave the parentheses out on this one, so I've got f minus g. I need the parentheses because we need to distribute the negative sign. If there's anything tricky about this section, it's that. That becomes plus 5. Combine like terms, we get negative x plus 7. Oh, I made a mistake. Did you catch it? This should be 2x plus 5. Then this should be 2x minus 5, and this should be negative x minus 3. Here then we multiply the function f times the function g. Hopefully you're realizing this is where we're going to distribute or FOIL. We get x times 2x. This is going to be 5x here and 4x here. That's 9x plus 10. And here we're going to divide f of x divided by g of x. Get x plus 2 divided by 2x plus 5. Alright, I kind of skipped over the domain. We're going to do those all at once. Here the domain is all real numbers. You can either write either of these. You can either write all real numbers, or you can do that fancy R. Ooh. Same there, same there, same there, same there, but not the same here. Alright, so here we go. If you'll look, in each of these A through E, we can put any number we want in for x, and we'll be able to calculate the answer. In F, we have to be careful. We can't divide by 0. And so, you cannot divide by 0. That's a no-no. We want 2x plus 5 to not be 0. So that means that x cannot equal negative 5 halves. Otherwise, anything else is fine. All right, some more practice here. Feel free to pause the video and then skip ahead and see the answers. Since I don't know g of 2 and f of 2, I'm just going to type this all in at once, or write this all out at once, I guess. Did I do that backwards? I did. So g of 2 is g, function g, 3 minus 5 times 2 plus f. F is 2 times x. I gotta put 2 in plus 3. So then I get 3 minus 10 is negative 7. 4 plus 3 is 7. 0. Nice. Cancels out. Alright, so here I've got g of 3 minus f of 3. So 3 minus 5 times 3. All of that, that's my g, minus my f. F is 2 times x, which the x is 3 now, plus 3. 3 minus 15 gives me negative 12. Minus 2 times 3 is 6, plus 3 is 9. Minus 9 gives me negative 21. GG, what does that mean? You got this. G of negative 4 times G of negative 4. We know G is supposed to be purple though, right? Ta-da! Here we go. G, we've got 3 minus 5x. X is negative 4 times 3 minus 5 times x, and x is still negative 4. Oh, don't do the 3 minus 5 first. We got to do order of operations. We got to do negative 5 times negative 4. That gives me positive 20. Here I'm going to get 23. Bust my calculator out for 23 times 23. 529. Maybe you know all of your perfect squares up to 100, huh? Or at least 25. Alright, here we go. Now, f is blue. We gotta take f of 5 and we have to divide it by g of 5. Excellent. So f is 2x plus 3. So we take 2 times x plus 3. My x is 5. Divided by g. G is 3 minus 5 times x, and x is 5. So we can then do 2 times 5 is 10, plus 3 is 13, over 3 minus 25, negative 22. All right. Took our numbers away, right? But it's still the same idea, except f is blue. So I take f of x minus g of x. F of x is 2x plus 3 minus g of x, which is 3 minus 5x. Distribute our negative sign here. We get 2x plus 3 minus 3 plus 5x. Combine like terms, we get 7x. 3 minus 3 is 0. Alright, fantastic. Alright, they're asking us about the domains again. X values. Domain of g of x. If you look at g of x, what has to be true about that? Well, hopefully you're thinking x plus 4 has to be greater than or equal to 0. We can't have any negatives in there. So the domain here is x is greater than or equal to negative 4. They want us to find part B here. You know what that is, don't you? F of x divided by g of x, which equals x minus 3 divided by the square root of x plus 4. Now they're asking for the domain of f divided by g of x. It's going to be similar, right? We still have the square root. The only difference is here, g can have 0 as an answer. The square root of 0 is 0. But what if we get the square root of 0 here? You see, we'd be dividing by 0. In this case, the domain is going to be the exact same. X plus 4 is greater than 0. The only difference is that greater versus equal to. Here we go. X is greater than 4. All right, here we go. Time for the difference quotient. The difference quotient really helps you prepare for something you're going to see in calculus. Right now, it's just kind of practicing notation. But in calculus, you'll use this, and when it's introduced, it'll be helpful for you to have practiced this. So the difference quotient is f of x plus h minus f of x all over h. So when it says find the difference quotient, this is what they're asking you to do. They're asking you to do this process to whatever your function f of x is. Okay? So let's take a look at it, give it a try. Difference quotient. We need to take f of x plus h, we need to subtract f of x, and we need to divide by h. So there's kind of two parts, the setup and then the simplifying. The setup is usually challenging. So I first need to do this. So I'm going to take f of x, which is 5 times x minus 1. You see that? I then need to take that answer, whatever that answer is, and I need to subtract f of x. Well, f of x is just 5 times x minus 1. And divide that whole thing by h. Now, in this first case, my x is x plus h. I'm putting x plus h in place of my x. In the second part, I'm putting x in place of x, which is a little silly, right? We've already done that. It's just 5x minus 1. Once you have this set up, two things to watch for. One, that you're distributing this negative sign here. And then two, just that you're distributing here and simplifying carefully. So let's take a look. I'm going to distribute. I get 5x plus 5h minus 1. And then I get minus 5x distribute plus 1, all divided by h. Now you'll notice 5x minus 5x is 0. Negative 1 plus 1 is 0. We're only left with 5h divided by h, which is really cool because now these cancel and I'm left with 5. Alright, difference quotient. For a new function, this is a new f of x. Still the same thing. Still going to take f of x plus h minus f of x divided by h. I would encourage you to pause the video and try this yourself. This time f of x is x squared minus 3. I then need to subtract f of x, which is just x squared minus 3. All divided by h. What goes in here? X plus h. You see how that works? Okay. Let's see. let's go off to the side here. I want to do x plus h squared off to the side. What that really means is take x plus h times x plus h, which means we have to distribute the x to both terms, distribute the h to both terms. So that gives me x squared plus hx plus hx plus h squared, which simplifies to x squared plus 2hx plus h squared. So over here, I was going to say I should have written smaller, but the cool thing about doing digital is I can. Here we go. I did this off to the side already. X plus h quantity squared is equal to that. So there I get x squared plus 2hx plus h squared minus 3. Distribute the negative.